I'm Anil Kumar sharing with you a very interesting question on indeterminate powers where we are going to apply L'Hospital's rule to find the limit. The question is to find limit when x approaches infinity for 2x minus 3 divided by 2x plus 5 whole to the power of 2x plus 1. Now, as x approaches infinity, the horizontal asymptote here is 1, 2x minus 3 divided by 2x plus 4. And if I write infinity here, it becomes 1 over infinity, right? Let me show you these calculations as some students might get confused. So what we can do here is we can write numerator as, let me take 2x common, right? So we get 2x, within bracket I get 1 minus 3 over 2x, correct? And in the denominator also I'll take 2x common. So we are left with 1 plus 5 over 2x, and this whole thing is to the power of 2x plus 1. Now, as the limit x approaches infinity, what happens? Have a look. When x is infinity, this term becomes 0, that term becomes 0, right? So you get 2x over 2x, which is 1. So this is equals to 1. And as x approaches infinity, we get 1 to the power of infinity. That is what we mean by indeterminate powers, right? Now, in case of indeterminate powers, strategy to solve is to take natural log on both the sides, right? So we have to take natural log on both the sides to solve this question. So it will occupy a lot of space, so I'll kind of squeeze in. So we can write this function as y equals to 2x minus 3 divided by 2x plus 5, everything to the power of 2x plus 1. So we'll take natural log on both sides. So we get limit, ln y, limit, we're talking about x approaching infinity, equals to limit x approaching infinity. So when you take ln, then we get this as 2x plus 1 times ln, the ratio of these two, right? So, okay, let's write ratio as such, then we'll elaborate, over 2x plus 5. Now, we could write this as limit x approaches infinity. We could write this ratio as limit ln 2x minus 3 minus ln 2x plus 5 divided by 1 over 2x plus 1, right? Now, we'll apply the L'Hospital's rule. We have already checked this as indeterminate form, 1 over infinity. So we'll find the derivative of the numerator and the derivative of denominator. So we get limit x approaches infinity. Derivative is 1 over 2x minus 3 times 2. So let me write this as 2 over 2x minus 3 minus. So here we'll write 2 over 2x plus 5 divided by 2x plus 1 whole square, and derivative will be minus, derivative of this is 2. So this is what you get, correct? So that's the derivative. Now we need to simplify this expression. You see 2, 2 and minus 2 is common, so you get negative. So let me take out this negative term outside, so we'll say negative, cancelling out all these 2's of limit x approaches infinity. And here when you cross multiply, you get 2x plus 5 minus 2x minus 3, and all this is multiplied by, this is minus 2, so it got cancelled. We cancel all these, right? So all this times 2x plus 1 whole square, right? And these terms come in the denominator. So let me write down this as 2x minus 3 times 2x plus 5. Try to understand this step. So we have taken common denominator, product of these two, which comes here, cross multiply. 2's we have already taken out and cancelled, and this negative sign is taken outside. 2x plus 1 whole square is written here. Because of limitation of my space, I've kind of squeezed in 2 steps here, but I hope the step is clear, right? So you can always have the intermediate steps and then get to this result. Now at this stage, we can write this as minus limit x approaches infinity. So if you solve this, 2x minus 2x is 0. 5 minus minus 3 is 8, right? So we get 8 times 2x plus 1 whole square. So I'll expand this, which is 4x square plus 4x plus 1, right? Divided by, we'll expand this also. We get 4x square. 2x times 5 is plus 10x minus 6x minus 15. Right? So this is what we get. Now we can write this as limit x approaches infinity. We can take 4x squared common. So we have 8. Okay, so we'll write 8 times 4x squared common. So 4x squared common. So we get 1 plus, if you divide by 4x squared, you get 1 over x. And if you divide this by 4x squared, you get 1 over 4x squared. Dividing by 4x squared, you get 1 plus, this is 10 minus 6, which is 4. Well, let me write down this as 10 minus 6 is 4, or okay, so this is 4x. So dividing by 4x squared gives me 1 over x. Is it okay? Because 4 divided by 4 is 1. And here we get minus 15 over x squared. Okay. Now, x approaches infinity. So when x is approaching infinity, all these terms here approach 0. So these terms, they approach 0. Now all these approach 0. So you're left with, sorry, I have to take 4x squared common here. Okay, so this is 4x squared. So we took 4x squared common, so we get 1, right? And at this stage, 4x and 4x gets cancelled. 4x squared and 4x squared gets cancelled. So this gets cancelled. Is it okay? Now we are left with, so as x approaches infinity, these 4 terms are 0. So we are left with, and these cancel out. So we get minus 8. Now this is actually, minus 8 is limit ln y when x approaches infinity, right? So this is, let me write this as again, or we get limit when x approaches infinity for ln y is equals to minus 8. That is what we get, right? Now, what is the limit for y, right? Since it is ln y, so limit when x approaches infinity for y, which is all this function, 2x minus 3 divided by 2x plus 5 whole to the power of 2x plus 1 equals to e to the power of minus 8, right? So limit when x approaches infinity for ln y is minus 8. So limit for y is e to the power of minus 8, right? So that is the answer. So we get this as e to the power of minus 8, right? So that is how we could actually solve this. So there's a lot of algebra going out here. You need to simplify your polynomials and get the result. But I hope you understand these steps. Most important is that when you get intermediate powers, like 1 over infinity, or sometimes you get 0 over 0, 0 to the power of 0, this is 1 to the power of infinity. In that case, you have to take natural log on both the sides to solve, just as we did here. And that helps to solve. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.